what happens at x equals -1. First example, there are 5 copies of x plus 1 in numerator, 5 copies of x plus 1 in denominator. They're the same amount of numbers. Simplify this, you get x minus 2 over x minus 3. The unfactor and the factor version are not equivalent until you put the x is not equal to -1. When you substitute -1 in, you get -1 comma 3/4. What does this mean? There's a hole located at x equals -1. Second example, there are 7 copies of x plus 1 in numerator and 5 copies of x plus 1 in denominator. Simplify this, you get the numerator x plus 1 quantity square times x minus 2 divided by the denominator x minus 3. Again, the unfactor version and factor version are not equivalent until you put x not equals -1. When you substitute x equals -1, you get -1, 0, meaning there's a hole located at -1. What's different from the first is that we actually know the hole is located on the x-axis. Is there a faster way of figuring this out? Yeah, there's an x plus 1 in the numerator. If you look at the last example, there's 5 copies of x plus 1 in numerator and 6 copies of x plus 1 in denominator. The denominator has more copies. Simplify this, you get the numerator x minus 2 divided by the denominator x plus 1 times x minus 3. In this case, we don't need the x not equal to -1 because there's still an x plus 1 in the denominator. Now, when you substitute x equals -1, you get -1 comma -3 over 0, meaning that -3 over 0 is undefined. This means that there's a vertical asymptote at x equals -1. Is there a faster way of figuring this out? Yeah, there's still an x plus 1 in denominator. So recap, what happens at x equals -1? If x plus 1 completely disappears, then there's a hole at x equals -1. If x plus 1 is left in the numerator, then there's a hole located at x equals -1, but also located on the x-axis. Last one, if x plus 1 is left in the denominator, then there's a vertical asymptote at x equals -1. Thank you.